Okay, let's continue. Okay, so we've got quite some questions now in the interval and also in the working groups, showing that many of you already want to start with the final assignment. That's really nice, and I think you also have already now quite some material to start. I would definitely work on milestone 4 before making the final decision, because for many of the projects in the past, it was clear that milestone 4 was sort of the technical basis. If you want to do something in machine learning, that is the obvious choice to do. But I want to give you a general introduction to what is the idea of this final project, or the final assignment as it's called. So that's, I'm now talking about the research project that I want you to write, that you want to do research on the working of methods in AI. So the task is that you find a research problem on which you can work on in order to investigate different AI methods or the same AI method in different environments. So some new findings about the AI methods that you've seen so far and next week. And of course, we need to bound this a bit. So we're looking at projects within the realm of Schnapsen, because I think it is still an unsolved problem that's quite interesting. As you might have already seen, but if you go to the Canvas page, there is a module about the final assignment, which contains a page of literature, for example, a research paper from one of the big conferences in AI, the HK conference, about Schnapsen and the different ways of doing something with the perfect information random sampling, Monte Carlo sampling, but also papers from students the years before to give you some intuition of what is expected. And the explicit research goal is that you also become acquainted more with how to do research should you be interested to become an AI researcher. So it's not a business report that we're looking for. It really is a scientific research report. And the idea to do that is to run this mini conference where we are submitting papers as if it was a proper scientific conference, using the proper conference submission system and becoming our own reviewers. So we run, in principle, the whole process of a research conference as we do that, as I do that if I'm a conference chair, for example. So I do that every couple of years or so. I'm somehow involved in organizing a conference, and I use exactly the same ideas, the same kind of paper writing and so forth. So that's why you get all those weird constraints, which are also described in the module about the final project, because this is how you make the papers comparable and so forth. So please keep to those, stick to those, because it's very important that we have these papers in these formats so that we can compare them properly. The general idea is, as I said, is to understand better the methods. So to do some research about those methods that we've seen. And the tool, of course, in which we can measure that is the paper that you write about it. So part of that is how good is your research, how complete, how do you prove all your things, do you only give us valid findings and so forth. And all of that is based on the analysis that you write down in your scientific paper. And in that way, it's also important that you write a good paper, because every reviewer can only judge your results of your research by the paper that you give it. So I think you have all followed some courses in academic writing, and you have already written research papers. So there isn't much new, I think, but I still want to give you some sort of my vision on how to write a good research paper. You can use this structure and this approach Feel also free to use a different one and maybe look around for other examples. So what I think a paper should look like is a title page with an abstract, and as opposed to what we did last year and what also still was said, I think, yesterday on the website, this year we run the submissions and the reviews anonymously. So do not write your name on it. There are different paradigms in the conference running as well. So there are anonymous conferences, and we have to run this as well. So you don't write your names on the papers. That'll all be managed by the system. Don't worry about it. But don't write the names on the papers, and we also don't have the names on the reviews, the peer reviews that you write. So you have the title page. The abstract should contain sort of the summary in a very, very short and concise way of what is this paper about, which is the research question I've tried to solve, where are findings, and done. So you give the overview over this is what's going to happen in the paper. Then you have an introduction in which you have to make really clear what kind of problem do you solve and what is the actual research question that you would try to answer, how you answer it, so your method. So the introduction should be a full introduction to the paper. Because actually what happens is, in practice, is that I think I'm a reviewer for about 15 conferences a year or so. And then you get 3, 4, or 5 papers to review. So basically I have 60 papers that I read every year. And I have very little time. So when I get those papers, and the deadline is there's one tonight, and I haven't started doing the reviewing yet, so I will take the paper and I will read the introduction, and sort of that sets the tone. So if the introduction, I fail to understand what the problem is, it's really difficult for the paper to convince me that it was good research. So the paper, although this sounds really unfair and it's not entirely true, but if you lose out on the introduction, your paper is guaranteed to go down in a conference. So make sure that the introduction really makes the reader interested in, that it completely shows the reader what you achieved, what you tried to achieve, how you did, and why the reader should continue reading. Yeah. The abstract is something where we use, for example, the abstract for choosing the papers we can review. So in the easy chair system that you will see as well, everybody can read the abstract when we bid on papers. So it should be, okay, this is a domain I can work with, this is an interesting approach, I'll understand the results, so I do a bidding on this paper and then I get the paper normally. So let's say that the reader who takes a minute should read the abstract, the reader who takes 10 minutes should read the introduction, and it's always the idea, okay, this should now motivate me to read on the rest. Okay, then we obviously know all about Schnapsen, we have the same background, but still it's important to have a brief introduction of what is the domain in which I work, what is the standard literature about the machine learning that I'm going to work on, so give all the relevant links to the literature, and give enough. That's a really important part of doing research. Yeah. Yeah, we have I'm also realistic. We have I think not even 2 weeks, 2.5 weeks to go still, so I know that you can't do all the full literature study, but in the guidelines it says if you have far less than 8 papers, you should think about it. And these can be on different levels. You can think of overview papers there are these 2 papers about Schnapsen that explain the rules and whatsoever, and then I use this specific technique in machine learning, and then you find 2 more papers in this domain to show. And I mean, you're working in groups of 3, so it means that if you have studied 10 papers, each of you have looked at 3, and that makes, I think, it's good enough. But there is no really good guideline for that. Yeah?
Is it will the paper count for 50% of the project or 50% of the grade?
50% of the grade.
Okay, because on the slide it
Sorry. It means that the papers are used for grading the project. So it's one thing. So it's the same. So you will only get one grade for the paper and for the project as a whole. Yeah. So then you have to describe what exactly is your research question. And it should be understandable for all of us. It should be concrete enough so that we can understand why you choose a certain experimental setup, and then you report neutrally on your results, give a table, point the reader in the tables where the interesting stuff is, and then interpret the tables that you give back in your finding section, in which you write down, okay, so there's an interesting drop in performance when I choose the parameter X. This is something that might come from, so here you can also try to give your explanation about several findings. So this might be because the memory gets so large now that we cannot search in depth sufficiently. These kind of observations can go to the findings, and in the conclusion you say, okay, this is what I did. It completely failed because my method didn't work better than RDeep. But we still understand that it takes a bit more time here and there, and give the essentials and keep it short. So if you look at the research procedure, so this is what really needs to be done, is take at least 4 bots. I mean, we have already given you more or less 3 or 4 bots. So the more you are comfortable doing some implementation work, implement new ones. They can be variants of each other. So if you have 2 different heuristics, they already count as different bots. You have a question, Don?
Yeah. Can you go back to the previous slide? So regarding the experimental setup, does it mean how we set up the environment, or write about the environment or something?
Yeah, I mean, we have no really physical environments to work on. So what you should describe is I'm evaluating the runtime of machine learning algorithms, and you want to check whether different algorithms have different runtime. So then you say, okay, in order to do that, we use a computer with these specs, and we ran 100,000 experiments where we had 500 times this feature applied, and we run all 7 different feature sets against each other, and then we get, as a result, we have this table. And we use this and this measure to say that this result is better than this result. Yeah, something like this. Okay, so compare the performance. You have different performance measures. You can say my algorithm works better because in the tournament it wins 70% of the time. And you have been given the tournament script, which you can also adapt, but this is a good starting point, and you can just use this one as well. But you can also study more things. So you can study different performance with respect to different environments. You can also study the runtime of things, of algorithms. You can also count, for example, instead of the runtime, you can count the depth that you have, that your standard algorithms use, and so forth. So measure different things, and make sure that the things you measure are relevant for the research question that you answer. And then just compare the different bots in some empirical experiments. Define your research question, and I think that is something that I really care for, is that you try to be as creative as possible with your research questions. And that can include some of the algorithms we've done here, but it can also be comparing the performance of the game of a certain algorithm with human performance. So set up an environment in which you have humans play against your bot, and check whether they really perform better or worse as opposed to some of the algorithms. So feel really free to look at all the different ways of comparing the working of an intelligent system. That can be internally, but it can also be really in a user study if you want to. Yeah.
For instance, the research question is if Minimax is more effective algorithm than RD, you still need to analyze the other bots as well.
No. But I would say this is such a limited research question because in a way, so why? What do you learn? So the question should always be, what new did you learn about the algorithms? So if you would say then, okay, I would like to study this, but then the depth of minimax, or the give me some interesting findings in this experiment. So if you just say, okay, my research question is whether bot A works better than bot B, what did I learn? I didn't learn anything.
Fair enough, but even if you have a more complex research question that focuses on one or two approaches, then with the first bullet, you still need to make a full analysis.
No, I mean, I think it's very difficult to come up with a research question that really has only two bots. But if you have a good explanation why you think this comparison with these two bots really is interesting, maybe it's if you have two bots and you have very different environments, then that counts as well. So we are relatively open about it. And if you're uncertain about it, check it with me. So my intention is that now Michael takes over the lectures, so I have a bit more time. So I probably organize a speaker for next week, so that we can talk 10 minutes about your projects if you want on a one-to-one basis. Yeah. So in the slides, and I will go to that very quickly. So that gives you some idea of how much space this could all have. And again, feel free to find your own style, but this is one which I found out to work for me. So abstracts very short, two paragraphs, introduction usually 2 pages, background information, in our case, 1 or 2 pages. The research question is really important, but it also doesn't need to be that long. It needs to be clear that we all understand what the question is. If we don't understand the question, we cannot understand the answer. The experimental setup contains all the things that you've done, and it should be reproducible. So we live in a world where research results are absolutely useless if they can't be reproduced. So make sure that someone who reads your paper knows how to reproduce it, how to run the same experiment. So all the algorithms should be there, should be linked somewhere, either cited, or you point to them in the appendix if needed. And of course, again, we have only 2 weeks left, so if we always have to do compromises. But in a real paper, nowadays, if you can't reproduce the paper, it's not a good paper. And then the results, you report on what you got in your results. Make sure you have a couple of tables in which you have systematically all the numbers. And my experience is always point in some bold, give the numbers that are, for example, statistically relevant. So it's always good if you have experience with statistical methods, run some kind of statistical analysis of your results, and show me the ones where you find a statistically relevant difference. And then you just put them in bold, and then you can refer to those in your text and say, okay, this is an interesting result. And that helps me as a reader to go very quickly to the interesting stuff. And the findings is then the interpretation of the results, give the explanation of what happens, and that can be a page or so. And it's only guidelines, as I said. And then the summarization of the end, what have you done, what is the impact of it, what is the future work maybe, what would you do with that later if you had more time. And I think that was it. So I'll be around probably in the next lectures on Monday and Tuesday if there are more questions, and I will organize a one-to-one session where you can come and pitch your ideas and get feedback. My really sort of question to you would be creative. It's always nice to see things that I haven't thought about, and we run the course now on the Schnapsen for 3 or 4 years. So I've seen a lot of good ideas, surprise me. That would be my request to you. Okay. So now happens what always happens, and that is that ethical considerations are squeezed somehow in a corner because of the lack of time or lack of energy or whatever. So we always think, oh yeah, it's incredibly important to talk about ethics and think about ethics, but then we have more important things to do. And then we do other things, and at the end, it's we'll have 25 minutes left to cover this topic. So I have one question about this have you had discussions about ethical implications of work as computer scientists or AIers before? Is this something where you would say, okay, we've done that so often, I don't want to hear it anymore, or is that relatively developed in your experience? So who thinks, oh no, my God, not again ethics? Okay, so who thinks this but didn't dare putting up their hand? Okay, good, thanks. Okay, so that's what I expected. And so I want to spend the last 20-something minutes on bringing up some issues which I think we should all keep working on all the time. Because we have a responsibility not only as academics, but specifically as academics in a field which has an enormous impact on society. And so if you think about how in the past 10 years of your life, the world has changed, and I can tell you in my life that the changes have been even bigger. So I remember still the time of the internet, the World Wide Web not existing. So the impact of what we see every day, all the new things, is enormous. And this changes also the way we live together. And we are the people who can understand possible consequences of what's happening better than anybody else, because we work with this technology before it is even applied in practice. So this gives us, I think, an enormous responsibility. And all I want to do today, because I'm not an ethicist, all I want to do is to sharpen your minds and your senses of, okay, whatever you do in the future, given the field you're working in, there is, in many, many cases, there is an ethical component that you should be aware of and discuss with your people, with your friends, with your peers, with your colleagues when you work on this. And here are some ideas about this. First of all, a little bit of background, but it's more almost randomly this discussion. So there's one main consideration: where do our ethical decisions come from? How do we get to an ethical decision in the first place? And there are, in principle, two fundamental ways of looking at that. The one is rule-based, is moral absolutism, and that basically means that we have some agreement, maybe on a religious level, that some higher power tells us this is the way we should behave. So the rules come from somewhere else, and this is then called the moral absolutism, where you would say, I behave ethically because there is an ethical rule system that tells me how to behave, and I'm doing good if I follow the rules of this system. And that's obviously which is some kind of approach that you find more often in religious people from religious backgrounds. The alternative is more on the modern philosophy. So we have Sartre, for example, as one of the people advocating. So if you don't believe in a God or in some higher power, it's very difficult to sort of find a reference for ethical decision making. But his position was that this puts us in an even stronger position as people, for example, because we need to argue for all the decisions that we take, whether they are responsible or not. So in a way, you can, as someone believing in some rules that come from external sources, it's easier. You can follow those rules, and as long as you follow the rules, you're fine. But for the people with the radical freedom, they have to sort of balance all the decisions they make in order to also come to some kind of ethical equilibrium or acceptable situation. So it doesn't mean that the one is better than the other, but there are two different approaches. And of course, most of us live somewhere in the middle, that we have and ethical rules that are agreed in our societies, and we try to follow those. But then we also, within those, we also see some freedom that we want to follow. That we have to also convince ourselves and others that the decisions we took in our freedom, from our freedom position, they are ethical. And both of them are, I think, parts of the ethical system that most of us probably will be dealing with. So one example from the science fiction literature is the robot rules from Asimov, and they are basically very much on the absolutism, the moral absolutism side of the spectrum. And basically, this is, I think, a famous example of 3 rules that help govern robots in society. The first one is robots may not injure a human being or allow a human being to come to harm. That's rule number 1. Rule number 2 is it must obey the orders given by a human, except that it would conflict with rule number 1. And then third one, it must protect its own existence as long as it doesn't conflict with rules number 2 and 1. So it's one way of giving the moral absolutist laws to a robot to decide what to do in specific situations. In a recent research project that we started here, basically with all the AI groups in the Netherlands, which is a big gravity proposal of more than 20 million euros. So it's really a big AI project in the Netherlands. Part of the research is whether we can sort of transform the ethical questions into the reasoning processes of the AIs, so that the AIs don't have only these kind of rules that you can check and say, yes, I have to follow these rules, thus I'm ethical, but that they also can develop their own ethical reasoning in order to make their decisions. Because those rules, they only have a very limited reach. So now to get a bit more practical, to get into the question of ethical dilemmas. So who of you have heard about the trolley dilemma? So most people have, but many have not. So the question is, the dilemma is that you see a trolley which has no conductor, whatever of the conductors. It rolls down a hill. You are having the power to change the path of the machine, and the question is, should you have it run to the 5 people, or should you switch it so that it goes down here and only kills 1 person? And I'd be interested very quickly if you could open the Menti on menti.com, and the code is H25700. And you can save 5 people by redirecting the train so that it kills only 1 person. Who of you would do it and say it's the right decision? Who of you would say it's ethically unacceptable? Who says I would throw a dice? And who says I don't care? Okay, so as this is a moral dilemma, there is of course no right answer. I think there is one wrong answer. And it's your guess which I think is the wrong answer. Yeah? So this is in a way, it's interesting in itself. It gives a moral compass. But now I want to change the game a little bit. And now this is the variant which is called the fat man variant of the trolley problem. And that is basically, you can push a very fat person in front of the trolley, and stop the tram that way so that it doesn't. So you actively push this guy in front of the train in order to save the other 5. Yeah?
Can't you jump in front of the trolley yourself?
No, it doesn't work. You're not heavy enough. So you really have to push this guy. Yeah? So who of you would push? It's the right decision. Who of you says it's not ethically acceptable? And who of you still goes for the wrong answer? So this is a question. This is a question that, of course, doesn't have a good answer, and I think we should, or it would be good to equip us with more analytic discussions in order to come out, deal with these dilemmas better. Because this is something that we face as AI people, as computer scientists, every day. Yeah. So this is not what I think is amazingly interesting is how much it changes for you to actively push someone or push a button. Because as you can see, the graphics really change. So it basically shows how difficult those things are and how bad, I would say, our compass, our ethical compass is. So basically, nothing changed apart from, in the one sense, we have a physical thing, but in the other, we push a button and the same happens. And it still changes our ethical compass a lot. Now, why is this relevant for us as computer scientists? Suppose you're a computer scientist and you write the code for a self-driving car. And I know that there are many different ways of doing this, but and it might not be very realistic, but suppose you have the decision of having programmed the car so that it crashes into 5 people who are standing on the street or crashing into the wall and killing the driver. Which one of the options you would program into? And here it's formulated very sort of generally in a direct decision, but you could also have yeah? Okay, can we keep it central, please? Yeah? Okay, so can I finish my sentence, please? Can I finish my sentence? So basically, this is sort of the most brutal way of making the decision if you have to write it directly into code. But as someone who works in machine learning, we all know that if you train a model on certain data, this is precisely decisions that you could almost explicitly make. So it's not that far-fetched as it might sound. So you had a point?
Well, I want to say, isn't it an option to let the driver choose beforehand which ethics program to follow?
That's a very good, no, but I think it's a very good question. That could be an option that I've chosen a different variant for a very similar question, and that is, which of the cars would you buy? Would you buy a car that kills the driver? Would you buy a car that crashes into the people? I do not know which car to buy, or I don't care. So I think that's the answer to your question that you have. Okay. So I think I hope that this makes 2 points. And the first one is that in these kind of questions, the moral compass that we have to make decisions in these situations is really very, very volatile. So changing a little detail, whether you push or whether you changes a lot. It also changes whether you're involved yourself. And there is no yes or no good solution, but I think it's something that we should all care about, because in many of the solutions that we choose in, for example, machine learning algorithms and applying them in practice, the consequences are rather close. So one way of dealing with this, sort of one technique that we could apply, is always is called the veil of ignorance, and that is that you do not know upfront in which of the positions you are put. So nobody tells you whether you are the one guy, the one more corpulent guy, I should call it maybe, in the second example, or one of the 5 people in the crowd. And then the question remains, what would you do if you were the one who would be pushed in front of, or the one in the crowd? And what would you do if you wouldn't know which one of the two you would be? So the veil of ignorance is basically, it's the same principle that if you have a piece of cake and you have 2 kids and you say, how can we now distribute this piece of cake? And then you tell your one child to cut the cake and the second one is allowed to choose the pieces. And that's where you get the best results. Yeah? Because the first one will go for the half-half solution in order to maximize its own cake. Yeah? Okay, so this was, I think, mostly meant as a signal for be aware how close these problems are and be aware of how complicated it is to make ethically right or ethically well underpinned decisions. So I want to end with 4 more dilemmas or kind of questions. And as I have only 5 minutes left, I give you 3 seconds for your question.
Yeah, I'd just like to add, when it comes to the moral dilemmas, if we each choose each make our own decisions, it kind of evens out over the distribution of options to take. But when you're an AI programmer and you program Tesla cars, for instance, then suddenly your moral compass, if we're not careful, becomes the norm for 1 million or 100 million cars.
Yeah. So I think I agree, and that is, I think, why we as engineers for AI techniques or computer science techniques, and also as academics, because we also multipliers towards others, have special responsibility and should also think of the consequences of what happens beforehand. So there is some new problems that are occurring, and that is one: how do we deal with AI? How do we deal with the AIs? And there is of course quite some movie material nowadays where this situation is exactly sort of becomes part of the game in the movie. So this is, what is it, Westworld, I think, where the computers, the AIs are allowed to be mistreated. And in the series, people realize, or the people watching realize that they are much smarter, and they really start to feel the pain of the treatment that we have against the robots. And this is related to the next slide, and that is why do we treat things differently between animals and AIs? Because the AIs now start also to deal with emotion and so forth. And we have in the animal world, we have this sort of gradient from mosquito. Nobody sort of stays still there, but it goes on and moves to many people becoming now vegetarian, but eating a cow is now accepted. But in this movie, Apocalypse Now, at the end, a cow is murdered, is killed to make the film. And there was huge protest that there was a cow murdered in order to make art. So even for different purposes, our ethical decisions are often not very clear. So it is allowed to kill an animal because we want to eat it, but it's not allowed to use it for sports. And if you translate, the more intelligent our computers are going to be, how do we deal with something that has at least a model of emotions and so forth? So there's a lot of questions that come. This was the one I skipped. That is the well-known Manhattan Project. So that was in the Second World War. German refugee researchers reported on Germany developing a nuclear bomb, and really encouraged the Americans to build an atomic bomb, a nuclear bomb themselves. And even after this, the threat from Germany was turned out to not to be a threat anymore. The American government applied this nuclear bomb on Japan, of course, as we all know, to tragic effects. And the people involved in this Manhattan project, they really struggled a lot with what they had done. So they had tried to sort of, at the moment when it exploded, when the technical success was in, they really cheered and there was a big party. But in the years to come, Oppenheimer was the head of this project. He really sort of suffered, and he became a figurehead of the questioning all of this and trying to stop the nuclear weapons to be distributed and so forth. But the question here is, for us as scientists, it's not always easy to see what happens with our contributions within the next 5 years or 10 years, and maybe our contribution might also end up in the nuclear in 15 years. And something that I think we should always be aware and always think very clearly. And one thing that is relatively close is, for example, the autonomous weapon. So the one I think that was used a couple of weeks ago or a week ago in Iran, it was one where the humans still making the decisions and also guided the rocket. But we're very close to developing drones which make autonomous decisions for killing someone. Imagine you have a decision algorithm like the one we built on our search trees, because that's easy to represent in a state space. And it now makes a decision of killing some people in Afghanistan or in Libya or wherever we have conflict. It's very close. And the way that the Dutch government deals with that is that it developed an approach where it says there needs to be a human in the loop. Okay, that sounds very good. But the way that the humans are in the loop is that they develop the algorithms. That is the definition of the Dutch government for the humans in the loop. You see how difficult, how dangerous this is, and that we are the people, as the people developing the algorithms, who also have to stand up and say, think through what you're just doing here. There's no time to get into the issue of privacy within 30 seconds, but you should be aware of, and probably you are, that the Facebooks and the Googles of this world, they know about 100,000 times more than the KGB and the Stasi ever knew about us. Yeah. So if you think of secret services knowing a lot in these times, think again what people know about you. They know about where we are at which second in the world, and it's all based on our technology that we are helping develop. And then this can be very often very misused. So if you apply machine learning algorithms, they usually apply some kind of probabilities, and you see what happens. You know what happens, that if you are not sort of the normal look from the outside, then chances are far higher that you get a profile, that you are searched, and so forth. And that is if you understand the technology and doesn't make any sense, but it's very often misused and used in wrong ways. So really thinking about how we use data, how we use data science, how we use AI is really critical, and we are part of an initiative which is called Responsible Data Science. And I really encourage you to make this one of the priorities also in your own way of dealing with intelligent systems in the future. And I think that was my talk. And so from tomorrow you will have Michael doing the stuff. Okay.